Welcome to VW 8.2. Today is simply an extension of 8.1, so this lesson I think is a lot easier than the last one. We're going to start by reviewing the range of the inverse function. So we've done this a ton of times. Hopefully now you recall. Cosine is 1 and 2, sine is 1 and 4, tan is 1 and 4. So I did it a ton because you really have to have that down. So first, let's take a look at this. Notice how the functions are different here, but fundamentally it's the same thing. The inverse on the inside, this is a triangle problem. Now the key for this is to understand the inverse is where the restriction lies. So we see tan inverse. So I'm looking at this one right here, tan. So highlight quadrants 1 and 4. I can see it's positive 1/2, which means the triangle must lie in quadrant 1 because it's positive. There's our theta. Opposite is 1, adjacent is 2. Do the Pythagorean theorem in your head. That is root 5 for hypotenuse. And now the question really boils down to this. Sine of theta equals what? Look at your triangle. That's simply root 5 over 5. No problem. Let's try another one here. Find the exact value of this. Highlight where the inverse is. That's clearly a triangle problem. So sine, that is quadrants 1 and 4. Now notice how it's negative, which means your triangle should be quadrant 4. So write negative 1 and 3. Again, do the Pythagorean theorem in your head. This should be 2 root 2. There's our theta. Now write cosine of theta. That's a over h, 2 root 2 over 3. No problem. Now I'll do a couple more. Let's try one with a tan and a cosine inverse. At this point, you're seeing these are all triangle problems. So it's cosine, so that's 1 and 2. And it's negative, which means it's in quadrant 2. Negative 1 is your adjacent. 3 is hypotenuse. You have 2 root 2. So the question boils down to what is tan theta, which is negative 2 root 2. So notice how triangle problems are pretty easy if the functions are different. It's really nothing new. Now, the next two are going to be a little tricky. These we can see, look where the inverse is located. These look more like circle problems because of where the inverse is. And it's a little tricky because these are two different functions. So I'm going to show you how to handle this with two methods. Our first method is simply evaluate. So for this one, what I want you to focus on is actually this. I want you to evaluate that. So sine 2 pi over 3, think about it, that would be root 3 over 2. So really this becomes cosine inverse of root 3 over 2. And now I can do your circle method. Highlight 1 and 2. Root 3 over 2 is right there. Your answer is 30 degrees, or pi over 6. That's a pretty good method. Now it's limited because what happens if you could not evaluate it? Well, in that situation, you're going to have to use method number 2. In this one, we can see it's the same idea, right? The inverse on the outside. However, none of you could figure out what sine 9 pi over 8 is in your head. That'd be pretty difficult. So what we're going to do is use a cofunction. Recall that the way to change a sine to a cosine is to do cosine and then take the complement. So do pi over 2 minus 9 pi over 8. So this thing should become cosine. That would be negative 5 pi over 8. And now look at that. Now it's exactly like what we were doing earlier. Now it's a regular circle problem. Cosine inverse, you highlight quadrants 1 and 2. Negative 5 pi over 8. That would be right about here. We can see we're not in the range, so reflect it over the x-axis. Boom. We're in the range. Our new angle is 5 pi over 8, which is our answer. 5 pi over 8. Great, so good luck on the rest of the problems. Once you're done, go on to the next part of the video. In this next part of the lesson, we're going to be talking about the inverse functions in regards to the reciprocals. So like cosecant inverse, secant inverse, cotan inverse, and a few other more abstract problems. But first, I'm going to give you the ranges of these. So cosecant is very similar to sine. It's going to be 1 and 4. So if you want cosecant inverse of 2, highlight 1 and 4. And some people think of this, where does sine inverse hit a half? That would be right below, that'd be right above. That would be pi over 6, right there. Now secant inverse, that's very similar to cosine. You're going to write 1 and 2. So I'm going to highlight 1 and 2. And again, some people like to think about cosine inverse of negative, do the reciprocal, that's a root 3 over 2. That would be right here. So that's 5 pi over 6. It's really nothing new yet. Cotan is the weird one. Cotan is not what people think. Some people want to make it 1 and 4, right? Because that's what tan is. However, cotan is 1 and 2. And the reason for that is because for cotan at 0, that one is undefined, and cotan of 90 is 0. So by spanning this, we don't hit any undefineds, because the undefineds are at the 0 and the 180 mark. Whereas tan is undefined at the 90 and the 270 mark. So cotan does change there. So for this one, you can highlight quadrants 1 and 2. And again, some people like to think of it as where does tan hit negative root 3 over 3, but I think for this one, just kind of think through it. You can think about quadrant 1 and 2, think where does cotan hit negative root 3? That would be right there. So that would be 5 pi over 6 again. Now here's our last one. Here's a more abstract problem. Highlight tan inverse of u. So notice how this is a triangle problem, but there are no numbers. So to do this, let's just kind of think through it. For an abstract question like this, just assume the variable is positive, because if it were negative, then you just plug it in anyway, so it doesn't really matter here. So let's draw a triangle in quadrant 1 like that. Let's call that theta. And here's the trick. Think of u as u over 1, because now I can write this as u and 1. Now by doing that, it's interesting because now I can actually find the hypotenuse. If I were to call this question mark, I can write 1 squared plus u squared equals question mark squared. Therefore, question mark squared should equal u squared plus 1. The question mark should be the root of u squared plus 1. So I'm going to erase this. I can write the root of u squared plus 1, and now I can figure it out. Sine of theta is going to be u over the root of u squared plus 1. Now you could rationalize that, but the book leaves it, so I'm okay with you leaving like this as well. Okay, so good luck on the rest of the questions. I'll see you in class.